At precisely 8:30 IMN on May 19, 2025, an SBU operator wearing FPV goggles received the long-awaited green light. Send it. Within mere seconds, a Ukrainian-made quadcopter drone, armed with 3 kilograms of high explosives, embarked on a 35-kilometer mission over the Black Sea. Its objective: destroy one of Russia's key surveillance systems and pave the way for Ukraine to reclaim strategic access in the region. The pilot, using the call sign Soil, operated from a concealed bunker located 35 km from the intended target on Snake Island. The drone, a 10-inch frame FPV quadcopter assembled in a Kiev workshop from Chinese parts just days before, was far from ordinary now. Secured underneath it, with zip ties, was a specially designed explosive payload, crafted to annihilate a radar system and incapacitate anyone within a 5-meter blast radius. Coordinates for the strike had been uploaded to the ground control unit well ahead of launch. The target, the Neva radar station atop Boyko Tower Alpha, a gas platform seized by Russian forces in the Black Sea. This wasn't just another piece of equipment. The Neva radar granted a 45-kilometer detection range that had hindered Ukrainian military activities for months. Disabling it would restore Ukrainian maneuverability across a crucial zone of the sea. This FPV drone was a prime example of how modern warfare is shifting. Precision attacks now achievable with a $500 zero-sense racing drone re-engineered into a smart missile thanks to Ukrainian technical resourcefulness. As the 4 brushless motors revved up to 20,000 RPM, the drone took off from a camouflaged launch site hidden in the reeds lining the shore. Unlike conventional UAVs, FPV drones transmit analog video feeds in real time, allowing operators to avoid electronic interference. Through his headset, Soil experienced a first-person view identical to the drone's own, forming a tight human-machine link that enabled pinpoint strikes on designated targets. The drone's flight plan had been meticulously charted to dodge enemy detection. Instead of heading straight to the objective, it would snake across the sky in a zigzag pattern, maintaining an altitude below 50 meters to remain invisible to radar. Traveling at a steady speed of 65 km/h, the craft would take just over 45 minutes to complete its 35-kilometer journey, given the evasive route. As the drone lifted into the air and began cutting across the sea, Soil watched the vast expanse of the Black Sea stretch beneath him through the onboard camera. Far in the distance, the Boyko Tower gas platform emerged from the waves. A fortress of steel bristling with Russian gear and personnel, all unaware of the approaching danger. By 9:15 a.m., the drone crossed its final stretch, and through his goggles, Soil had a clear, uninterrupted view of the Boyko Tower. The massive structure jutted 40 meters into the sky, and perched on its uppermost deck was the Neva radar, a system that had monitored and compromised Ukrainian movements for weeks. This radar wasn't some outdated relic. It was one of the few Soviet-era systems still delivering dependable performance. Operating in the K-band at 35 GHz, it featured a rotating antenna capable of detecting air and sea targets within 45 K-band. It stated, the rotating antenna capable of detecting air and sea targets within 45 K-band. Even more crucially, it could monitor up to 200 targets at once and provide data to Russian weapons across the northwestern Black Sea. But even the best engineering couldn't stop a high-speed drone loaded with explosives. The 3 kg device beneath Soil's drone, while small, would be catastrophic when aimed at fragile radar components, transmitters, receivers, and waveguides. Through the drone's lens, he spotted Russian soldiers moving about the lower decks of the tower, completely unaware of the fast-approaching threat from the northeast. The Neva radar kept sweeping in a steady arc, each rotation inching it closer to potentially identifying the inbound drone. However, FPV quadcopters are notoriously hard to detect, thanks to their minuscule radar signature, which is roughly comparable to that of a large seabird. At a distance of just 800 meters from the objective, Swa began initiating the final phase of his flight. The strength of FPV technology lies in its unmatched accuracy. Unlike traditional munitions that rely entirely on GPS targeting, FPV pilots can manually guide their drones and tweak their path right up until the strike. Through his goggles, Soil had a direct visual on the precise impact point, the joint where the radar's antenna met its control housing, a weak spot that would inflict maximum damage on both hardware and circuitry. On screen, the Neva radar system loomed ever larger. While Soviet engineers had constructed it to withstand signal interference and severe weather, they had never imagined it might be hit head-on by a guided explosive drone. The casing around the radar was made of lightweight aluminum panels, built to resist elements like sea spray, not to absorb the force of a 3 kg bomb hurtling toward it at 60 km/h. When the drone was just 200 meters out, Russian crew members finally noticed something. Through his video feed, Swal could see them yelling and gesturing frantically, but the window for any defensive response had already closed. The drone was moving too fast, too close. One technician reached for what appeared to be a firearm, but impact was inevitable. In under 10 seconds, it would all be over. At 9:20 a.m., Swal's FPV drone smashed into the Neva radar's antenna cluster with pinpoint precision. The payload detonated on contact, sending shards of metal, electronics, and structural debris flying across the upper levels of the platform. It wasn't a massive explosion by battlefield standards, but its accuracy made it catastrophic. The radar's fragile waveguide array was obliterated, the transmitter demolished, and its rotating antenna mechanism completely disabled. With a single, meticulously delivered strike, a drone that cost less than a yearly Netflix subscription had taken out one of Russia's top surveillance tools. While the remnants of the Neva radar smoldered from 80 kilometers away, another, far more formidable weapon was silently making its approach toward Boyko Towers. Though not yet fully verified at the time of this reporting, it's widely believed that this second weapon was already en route. Gliding low across the waves, the Sea Baby drone embodied the cutting edge of Ukraine's maritime strike capability. This 6-meter-long unmanned surface craft was carrying nearly a metric ton of high-grade explosives toward the Russian-held offshore platform. Unlike the repurposed FPV drone, the Sea Baby was a purpose-engineered vessel, built from the ground up at an SBU facility specifically to take down fortified sea-based targets. With its sleek, compact hull, it more closely resembled a coastal patrol boat than a lethal unmanned weapon. Yet, beneath that sleek exterior hid 1,000 kg of combat-grade explosives, enough to obliterate a small city block. The Sea Baby's warhead was a triumph of advanced explosive design. Instead of relying on a single detonation, it used an array of shaped charges positioned along its bow, arranged to produce a chain reaction of explosions upon impact. This layout created a phenomenon known as a sympathetic detonation, where the primary blast triggered sequential secondary charges, resulting in a drawn-out explosion capable of tearing through even reinforced concrete structures. The explosive composition combined RDX and TNT, delivering both sheer blast force and sustained burn temperatures surpassing 3,000 DGC. If detonated against the Boyko Tower's supporting columns, this warhead wouldn't just damage the infrastructure, it would produce a fiery inferno capable of melting steel beams and pulverizing concrete. Despite its name, the Sea Baby was anything but slow. Propelled by twin 200-horsepower inboard engines with jet propulsion, it could hit speeds of 49 knots while skimming just above the waterline, minimizing visibility. The dual-engine layout offered a failsafe. Even if one power unit failed, the drone could still complete its mission on the remaining engine. Despite the drone's autonomous capabilities, human operators maintained manual oversight through secure, encrypted satellite communications, enabling real-time adjustments for a pinpoint strike. This remote link allowed operators to fine-tune the drone's course and pick the ideal impact site moments before detonation. Its design was optimized for both stealth and resilience. The vessel's low-profile hull kept it beneath typical radar coverage, while its muted gray color blended seamlessly with the turbulent sea surface. Crucially, the Sea Baby drone came equipped with several backup communication channels. In case the Russians attempted electronic jamming, the operators could instantly switch frequencies, preserving full control. What made this particular mission especially lethal was the nature of its target. Unlike previous strikes aimed at moving naval vessels, the Boyko Tower was stationary, fully charted, and well understood. Ukrainian intelligence had mapped out the platform in detail, including the positions of storage tanks, personnel quarters, and load-bearing columns. With this knowledge, the drone could be directed to inflict maximum structural damage. Closing in at 45 knots, the CB's warhead embodied the peak of Ukrainian asymmetric warfare tactics. 1,000 kilograms of engineered explosives aimed directly at the heart of a Russian-controlled offshore base. At 9:15, the drone was only 30 kilometers away and closing in rapidly. Its high-resolution optical system streamed live visuals to SBU operators, showing the Boyko installation growing steadily in frame. The plume of black smoke from the earlier Neva radar destruction was still visible in the distance. But the radar wasn't today's objective. It had already been neutralized. The new goal was to destroy the platform entirely, ensuring it could never again serve as a strategic outpost for Russian operations. The approach route had been carefully plotted to catch defenders off guard, while exposing the drone to minimal risk. With Neva out of commission, Russian personnel on the Boyko Tower had virtually no means of detecting incoming surface threats. Their only remaining defense consisted of visual observation and short-range communication devices. An outdated defense posture with no support within 100 kilometers. Through the drone's camera feed, the operators could now see the full layout of the sprawling Boyko Tower complex. The structure spanned several interconnected tiers, featuring metal frameworks that housed fuel storage, technical areas, and sleeping quarters. Russian forces had retrofitted the gas extraction facility into a fortified base, complete with antennas, supply depots, and defensive emplacements designed for sustained military use. As the Sea Baby closed in, its autopilot carried out continuous adjustments, hundreds of tiny corrections every second, to keep it on an optimized trajectory. Unlike human pilots, its onboard computer processed GPS inputs, inertial sensor data, and visual targeting simultaneously, ensuring the drone stayed locked onto its path with mechanical precision. By 9:35, just 10 kilometers out, the CB initiated its final targeting sequence. Its advanced optical suite homed in on the main structural link between the living quarters and the central drilling platform, the exact section known to house Russian personnel. This wasn't a random strike. It was calculated for maximum impact, both tactical and symbolic. Ukrainian intelligence had precisely identified a structural weak point. Destroying it would cause the entire platform to collapse into the sea. The CB had accelerated to its top speed, hitting 49 knots, about 90 km/h. At that velocity, the 6-meter-long craft effectively transformed into a 6-ton battering ram, loaded with a 1,000-kilogram warhead. Even without explosives, the raw kinetic force would have been brutal, but combined, the outcome was nothing short of annihilation. By now, Russian personnel on the Boyko Tower had spotted the incoming drone. From the CB's onboard camera, SBU operators watched as figures scrambled in panic. Some sprinted across the deck, others raised rifles, and a few barked orders into radios. But all of it was meaningless. The drone was under 5 minutes from impact, and none of the weapons on site could even hope to intercept it. The defensive setup on the platform was laughably inadequate against such a threat. A few assault rifles and maybe some mounted guns were present, good for deterring saboteurs, perhaps, but utterly useless against a sea-skimming, high-speed drone. The CB's ultra-low silhouette and blistering velocity made it nearly untouchable. At a distance of just 2 kilometers, the drone locked into its terminal approach. No turning back. The 1,000-kilo payload was seconds from converting the Boyko installation into scrap metal.